guys. Today I'm gonna cover the core idea of moving average, which is the uh, traditional classical model for forecasting in time series forecasting. And today I am going to cover about the simple moving average and weighted moving average here in this video. So yeah, simple moving average and generally moving average is the technique used to smooth out short-term fluctuations, high longer trends or cycles. If you have I'm gonna share. I'm gonna okay. Is it visible? Yeah, yeah. Here you have in data. Here you have in data that. Here is a time series visualization, time series plot. Uh, here is an fluctuations of high, here is an seasonalities also you can see, and the high fluctuations, and there is no, it is a sideways trend. Let's say yeah, it is fluctuating data time series. So here how the uh, our moving average models, which are classical models, gonna performs is just like calculating the average of the all individual data points, as summing of finding just average of the time series, and that average gonna be the predicted value uh, from for the predicting value gonna be the average value of the time series. The core idea after moving sorry of moving average is just averaging, and here we have a simple moving average and weighted moving average. Here is to this is generally a smoothing technique, like neglecting the short-term fluctuations, like the high uh, what do we call it as a strike, yeah, let's say it's an strike, and it neglects the high fluctuation, the strikes, and calculate the average from the all time series and plot the graph. uh, Here is I haven't plot the moving average of this graph, but the working principle of the moving average is like uh, considering high strike and low strikes and cancel out each others, and finding the average of them and tracings all in the plot. That's the core idea. And it works as a model, which is a classical model, or we say it is as an baseline model. um, it works as a baseline model to evaluate the complex models. We can use this classical model, this uh, simple moving average, let's say as a gist is the moving average models as a baseline models to check whether our complex model is performing well or not. It is helping there. Mainly we have a different complex model like Arima, Sarima, and Sarimax, and multiple models provided by stats model. We definitely gonna cover in upcoming sessions. For now, let's more discuss, more dive into the moving average techniques. uh, yeah, without any further delay, let's get into the simple moving average. As I have already spoken about simple moving average or moving average, uh, core idea is calculating average of the time series and predicting a predicted value is that is the same average value, and the simple moving average is the most basic form. It calculates the average of selected range of data points, the window or a period by giving equal weight to each data point in that window. So you will fix the total number of data points, like you will fix the range. If you have 100 data points in the time series, and for calculating the moving average you're gonna fix the range, like uh, first 10 you're gonna split the time series in equal parts, let's say, like not equal parts. Generally you can define the range only like 7. Let's calculate the, just you can say like this, let's calculate the average of moving average of 7 data points, and for next time another 7, and for next time uh, going simultaneously, next 7 data points, like if you have a first 20, and you're gonna add. Okay, I wanna display, I will show you the actual what I mean to say is, here you have an example calculating a 3D simple moving average for daily sales. We are calculating the moving average of the daily sales here. First, we have 6 days of 6 days data. First is daily sales of $100, 10, 100, 10, 90, 130, and so on. And calculating 3 days, 3 days simple moving average is calculated as first 3 days. Like in the third one, why we didn't calculate the moving average in first and second days is we don't have the uh, previous data before the one first day, like before the $100 sales. We need at least 3 data points to calculate the moving average in this context. Uh, so we define the 3 as an range of the data points, and from the third day we started calculating the simple moving average as a sum of first 3 data points, 1 2 3, from the day 1, day 2, and day 3, and divide by total number of data points. That's an actual what basic formula of the to calculate the average. And 3 day simple moving average came out to be 100, and so on for 4 5 6. But we are not going to exclude the included data points in the earlier process of calculating the moving average. You can see here, like we excluded one data points, that is day number 1 data, total daily sales of first day, and include other remaining 2 days, and new one is here, the day 4 sales, and another 3, with sum of them and divide by total 3. That's an average meaning, and we found out to be 110 as a moving average of first second 3 data points. And we go continuously in the same way and find out the 3 day simple moving average. Yeah, this is an actual row of moving average, and that's how the simple moving average is performing uh, the entire process. And this all gonna be the predicted value. Notice how the smooth simple um, line would be less volatile than the raw daily cells. It means that if you plot this in a charts, and you will not find like the sharp edges in this time series. You will find the uh, line, curved line graph. They will find graph rather than the sharp points, the fluctuations. Cause why we won't find the sharp edges, sharp data? Because those sharp edges, the peak values are used to calculate the mean, to calculate the average. So they are deduced, they are deducted there, so that they won't be seen in the while we plot. Yeah. And we have the main what is the main, the core things of the simple moving averages. It's consider all data equally. It treats all data equally. Like if you have in the time series, we generally uh, don't prefer the old data. We generally prefer more the newest data to predict the next one, to predict the futures. But it is like a cons for the simple moving average. It consider all the data points equally, treat equally. It gives it gives equal priority to the early data and the latest data. So this is the cons of the simple moving average. Talking about the pros of the simple moving average, uh, can we calculate easily, understand very easy to understand, like calculating normally s- average, that's gonna be okay. That is the logic behind the simple moving average, not more than that. And effectively smooth out noise to reveal the trend. Like uh, you will find the trend, uh, and you won't be confused in between it's a noise or it's a trend. It will show that it will reduce the noise and focus on the trend. Like if the trend is uptrend, and if the trend is uptrend, and you will definitely see the uptrends clearly, without any doubts that it is noise or what you will not be confused in that step. So the main advantage, then pros of the as simple moving average is that. And we have cones like lag. It's always lag behind the current data between it based on past data. Yeah, of course it's all models based on the past data, though it mainly focus on the, not in it mainly, but it focus to all the data. So I told you earlier about this also. Equality weighting means it gives all priority to all the individual data points. And spike sensitivity. A single outlier or spike within the window can significantly skew the average. Yeah. Here in the example, if you have 200 instead of 130, the moving average gonna be more than the actual one. Like let's say here 200, and let's sum of this 200, 300, 400. 400 divided by 3, yeah, more than other. It will be the, if we plot the data, if we plot the graph, and you're gonna find like let's go here. Here like smoother one in all cases. It's smooth, and in instant point it could be like high pitch one. Yeah, and like that's then other cons for the simple moving average. I have code here, and this all I have input all the libraries, all the uh, uh, functions here to use it in afterwards. But this this stack models, the libraries provided by the stack models is not used yet, but it will be used in further uh, studies. Yeah, not for now. We can simply calculate. I have an data sets of UK cell, the UK based data sets that are time series data, time series data of cells, monthly cells, and this is the loading phase of data. Here we have checked about the data descriptions, and yeah, naive model. I won't talk about naive model for now. I am in the simple moving average for now. Yeah. No more complexities, no more complex calculation computations in the simple moving average. Like you can do it with the only two line of code here. Total quantities are the target to find out to predict, and we used a single variable for here calling Windows 7 means we will calculate the 7 data points, the mean of the average of 7 data points, and the last gonna always be last one will be the predicted value. Like you have a list of simple moving average. Yeah, you have a list of first, second, third, fourth, fifth, or sixth one, and the last simple moving average value gonna be the final answer or final predicted value. How this is like last one will be the latest one, like the last one of the calculator value will be the latest. Why? The last data point we entered here, you I on the sixth day, the day six, the cells of day six is the latest data we have passed into the to train the model, and finding out the last moving average will our predicted value. Yeah, that's why use the -1 means the last value. That's the simple Python logic, and this much for the simple moving average forecasting. Now let's dive into the weighted moving average. Weighted moving average is not more complex and not more than the simple moving average. It just give the more priority to the latest data. It gives the high weights to the latest data. That's the major difference between them, and which helps in the time series so much. Like um, we don't need to give the more priority to the world data. Like the next step, the next value, next cells. Let's talk about the cells. The next cells which we will predict uh, is mainly uh, affected by the latest today's cells or yesterday's cells, which is our latest data points, rather than the earliest the day one cells. So the weighted moving average consider all more for the latest data, then the oldest data. Yeah, formula is so simple for the weighted moving average. Here you can see you will assign weights to each data points, but main thing is you gonna assign the least weight to the old data and high weight to the newest latest data. Yeah, the summation of product of weight and the data points divided by sum of weights. That is the main formula for the weighted moving average. And here you can see a sample data example. Uh, Here this is 1, 2 and 3. I think it or not. Okay. P is the value and W is the weight assigned to that value. Yeah. This is all about notations, and this is P and this is W. P cross W, the whole is the summations and the total divided by 6 means we have considered first all 6 data or what. Oh no, sorry. Sorry. This is not a number of data points, but it actually the sum of weights that we assign. Like W1, W2, and W3, we sum of these all three weights and find out the six as in total weights, and we multiply all the data points with the weights, and uh, lastly we sum this and divide by total weights, and yeah, you can find the weighted moving average. Here this all step are is same, and 110 90 is first 3, and again another 3, and again another 3. We want to exclude data, though we will exclude the first one for moving backwards, but we want remain independence, remain unused. Yeah, that's all about the simple moving average and weighted moving average. The weighted moving average is higher because it gave more weight to the recent spike. Oh, sorry, I said strike, but it actually is spike, right? Of $130. This makes it more responsive to recent changes. Yeah. Why the weighted moving average is greater than simple moving average is generally it gave more weight to the recent data, though simple moving average used to give equal weights to all the data. That's why comparatively weighted moving average is higher than the simple moving average. Okay, let's talk about the pros of the weighted moving average. More responsive, it react faster to recent change than a simple moving average. Reduce lag. The lag is generally less than simple moving average with the same window size. I am not clear about this point, but I'll sort out this one. More complex to calculate. Yeah, it's more complex to calculate. Look, you can see here. First, we have randomly made a numpy array of weights, and weights is weight divided by sum. And this we have calculated. We generally didn't assign one as an weight, but we find out that one placed one and some of these all means we scale down the weights and assign it and to our each data points. And weighted moving average forecast average of it and this, and I look at last 7 columns of the trend sets. Weight equals to weight, that's what we passed as in weights. uh, and here is uh, this line of code will tell you about how long predictions value we gonna store in the data. Like if you have the total length, how much? If you have 10 test data, 10 different rows of test data, then you will definitely need 10 predicted value to evaluate the matrices, to calculate the accuracy and all the other stuffs. So yeah, this will handle the all forecasted data from above. Yeah, that's it for weighted moving average, and we have plotted weighted moving average and the simple moving average in the plots. Yeah, here you have an index. This blue color time series is trends and data, and orange as an test. Red is actually weighted moving average forecast. Like they both are smoothing techniques, so that not a sharp, like not a curvical path, not a curvical prediction is made, but it's both are linear. And the main reason behind this is they don't consider the short-term fluctuations, seasonality. Yeah, there one. Here you have simple moving average and the weighted moving average, and they are actual how they are differ from the is like the data is it won't consider this sharp that noise I said the pitches, but it will find the average predictions, and which you can see in this screen. Yeah, that's all about the simple moving average and weighted moving average for now. I wanna end this video, so yeah, thank you.